Welcome. Good day. Welcome. Happy Friday. It's probably Monday for you, but it's Friday for me. So we've got a little video, and it's called The Chain Rule. That's what it's called. It doesn't say it anywhere, but so far we've been taking derivatives of things. And so we can take the derivative of all these things. We have the rules that'll help us to get this, to make this happen. We could find the derivative of 2x squared plus 3. I think it'll go full screen. Oh, much nicer. So 2x squared plus 3, we can find the derivative of x squared plus 1, and 3x squared plus 5, and we can find the derivative of 5 over x to the 4th. Okay? At this point, we could not find the derivative of this. Yeah, well, this one we could sort of, if we're careful about it, did a little extra work, but we can't easily find the derivative of that yet. Nor could we easily find the derivative of this one yet. And we certainly could not easily find the derivative of this one yet. And finally, probably couldn't find the derivative of that one easily yet. But when we have the chain rule working for us, we will be able to do that. Okay? So I'm going to roll back in the chair. I'm going to go to the board and the dowel demonstration. I'm not sure how the sound's going to pick up. I'll try to talk loud as we run through this piece, the board and the dowel demonstration. Okay, be prepared to be amazed as we step back here. You can see behind me, we've got what looks like a board and a dowel, but really it's a whiteboard. And if I put the dowel right here, you can see the dowel, it's right there. I put it on the board, and roll it down, surprisingly enough. Okay. What that looks like that. So we can pretty much predict the speed as this thing rolls down the hill. Okay, you can see it up close. It's actually got a little BYD action. You can't really tell, but it's there. So that's an easy one for us to be able to predict. The problem then becomes if I start rolling this down the hill, and as I'm rolling it down the hill, I change the slope of the hill. So I've got two things going on. I'm rolling down the hill the way it wants to roll, but I also do things like while it's going, it changes the predictability, our ability to figure out what's going on here, or if I do, like I do this sort of thing as it's going down the hill, or flip it side to side, it's going to impact it. So when we have more than one thing changing at a time, we need some other way to figure out, and I hope you could even hear that, to figure out how, to figure out how to find that rate of change, how that dowel is changing as it goes down the hill. So we have this little thing called the chain rule. And the basic thing in the chain rule we're going to start with is the derivative of something squared is 2 something d something. So twice something times the derivative of something. Think about, derivative of x squared is 2x. Okay? Derivative of something squared, anything squared, is 2 times that something times the derivative of that something. Let's go with, well, first let's expand that, and then we'll go with the derivative this way. So if we expand this, we're going to do, I'm going to go the fast way. The first thing squared is 4x to the 4th. The last thing squared is 9. Multiply those together, 6x squared. Double it for the middle, 12x squared. Take the derivative, I'm going to end up with something like 16x to the 3rd plus 24x. That's it, right? Now let's go to the chain rule method. Chain rule method works sort of like this. The derivative of something squared, this is my something, it is 2 something d something. Derivative of 2x squared plus 3 is 4x. Expand all that out, so it's going to be 8x times all that. 8x times 2x squared is 16x cubed. 8x times 3 is 24x. Behold, same thing. Didn't have to do the intermediate step there. So 2 something d something. That's a general sort of odd way to go about it. The chain rule works like this. We're trying to find the derivative of y with respect to x. First, we find the derivative of y with respect to some other value. And then we multiply that by the derivative of that other value, that other thing, I should say, not value, that other variable, that's maybe the word I'm looking for, with respect to x. And so if you think, in terms of the way fractions work out, these two sort of cancel each other out. They don't really, but it's kind of that chain reaction. If I can figure out how this one's changing with respect to that, and then I can figure out how that one's changing with respect to this, change this a little bit, then that one's going to change the same sort of thing, and I get the combination of the two. I'll show you what I mean. I think. Yeah. All right. So if I'm trying to find the derivative of this cubed, something cubed this time, Okay, something cubed, I say, well, what's that something? That something is x squared plus 1. So when I take those two pieces, this really is just u to the third power. Okay? And then the derivative of this with respect to u is 3u squared. See what I did there? That's the derivative of that. On this side, I've got the derivative of x of this u with respect to x. What's the derivative here? 2x. So I'm going to put those pieces together. dy dx, which is the derivative of this thing that we started with, is going to be dy du, which is 3u, and I'm not going to write u, squared. Put it right there. Okay, 3u squared times du dx, and du dx in this case is 2. Okay, du dx, like that. Okay, last thing I'm going to end up doing, probably, or second to last thing, is I'm now going to back substitute in x squared plus 1, and then make it nice. 3 times 2x is 6x times x squared plus 1 quantity squared. That's about all I can do. That's, if we like, f prime. If you look at it, I did the same thing we did with something squared. The derivative of something cubed, 3 something squared, d something. Okay, that's leading us maybe to the general power rule. This, of course, is the famous general power. That's just who he is. He splits him like a general. So the basic thing, derivative of u to the n. So anything, something to the nth power is n something to the n minus 1th power times the derivative of that something. Okay? So we use the old power rule and multiply by the derivative. So that's what that u prime thing is. That's why everything's in terms of u, because used like that. Universal, it could be anything sort of deal. All right, so now to get to the derivative of the cube root of 3x squared plus 5. And I know that I've told you that whenever you see something like the cube root written down, just go right to that form right here. Don't bother with the cube rooty thing, okay? So now, let's do the chain rule. And I'm just going to go with, I'm going to try to go like sort of the intuitive way. So the derivative of something to the third power is 1/3. That same something to the, subtract 1 from 1/3, we get negative 2/3. Okay, so 1/3 something to the negative 2/3 times the derivative of that something, the derivative of 3x squared plus 5 is 6x. Now, make it look nice. So let's see, this is certainly, we're going to end up with a fraction because I've got some negative exponents. This certainly going in the bottom. The positive 2/3. 6x can go up top, the 3 on the bottom, but I'm going to probably go 6 divided by 3 and just make it a 2x. Okay, 2x goes 6 divided by 3. And then I'm done. And that's my derivative. That's how, whatever this cubic function here, whatever it's modeling, whatever it represents, that's how it's changing anywhere along. We could evaluate it. We could get a number if we needed to. But again, we're just sort of playing with expressions, trying to get used to all the rules. Okay? Another one. Rewrite right away. 5 times 3x plus 7 to the negative 4th. Okay? So we're going to go with that f primed. Okay, derivative of something to the negative 4th. We're going to just follow my rules. Negative 5 times negative 4 is negative 20. Something, don't change that piece of stuff, to the negative 5th. Okay, got to include the derivative of the something, 3. Okay, this is something. That's what that says, I think. And this is derivative of something. Call it d something. Alright, that says something, all that's there. Okay? So, now we just need to make it look nice. The only thing we can do to make it, well, a couple things. 20 times 3, negative 20 times 3 is negative 60. Get rid of that blessed negative exponent, like so, and we are all set right there. That is my f prime. Okay, one thing, notice that when I have a function, I can make it equal. When I take a derivative, I always write, I'm taking a derivative, but I don't write all that out. I write f prime. All right, where are we at now? Oh, we're there. We're at the end of the road, the end of the run. Okay, so generally speaking, this chain rule is one that we will use forever and ever because not everything's just x. We're not looking always at really nice, fun, simple functions like we have been so far, where everything is just about x to some number like so. Right? We're going to see functions that are all sorts of extra crazy like these are here because that's the way things are. They don't just vary. They don't just go with like a nice, simple piece there. All right, so flashing ahead, there it is. That memory quiz is coming up pretty soon, like probably tomorrow. That's the problems we're going to work on at some point, probably the next day. So there you have it. Okay, I think that's all I've got to say for right at this moment. And let's see what goes on there. I get this out. I'm 10 minutes 22 seconds. That is excellent. I think perhaps is a world record for the chain roll. And I've talked enough. So thanks for listening. Thanks for watching. I hope you learned something. See you real soon. If you have questions, you know you should ask. See ya.